In this tutorial, we'll master the repeatable read transaction isolation level, which resolves most of the anomalies we've discussed. However, there are still some anomalies that this isolation level can't cover. So watch this video until the end to avoid such anomalies in your projects, and let's dive right in. Repeatable read definition is vary from database to database. In this video, we'll focus how it works in Postgres, but if you use some other database, better to double check documentation before using any transaction isolation level. Alrighty, what is repeatable read at the first place and why it has so complex name? Let me break it down for you. Imagine that you would like to make a snapshot of the database, and during the snapshot you would like to make as many read as possible and expect the same results within the transaction, obviously. This is actually what repeatable read does. It provides you with a guarantee that you can read the row or set of rows multiple times without seeing changes. They claim that it solves all of the anomalies except of the serialization. Alright, let's check it out. Okay, let's start from non-repeatable read anomaly. As you remember from the previous video, it happens when we read the same record multiple times within a transaction, but see different results. So let's have a look if it happens with repeatable read transaction isolation level. So I will use the same example with the accounts that we had. So for that, we need to insert some records first. Then I will begin the transaction. Then I will read the information about all of the accounts. And as we can see, here we have savings, checking, investment account. In total, the balance is 20,000. And let's start another transaction, which will update the savings account. It executes update and commits. Let's check the sum now. So as far as we use repeatable read, we kind of made a snapshot of the database and it shouldn't show us this 200. So it should be 20,000 as illustrated over here. Let's prepare the statement and execute it. Yes, and it's 20,000. Before, when we had read committed transaction isolation level, we saw here 20,200, and it's kinda would look odd on the report, even though the data is outdated. So kinda when we made a snapshot, we would like to make a consistent result. And this is when repeatable read comes in and better to use it. Now, like if I would implement this application, my application would return consistent result for the report. I hope that makes sense. Okay, let's revisit last update anomaly. As you remember from the previous tutorial, it happens when I start a transaction, then you start a transaction, and then make an update and commit your transaction. Then I continue my transaction and make an update also. So in the end, your update will be lost. I will override it by my commit. So, and this is the issue. We lost your update. Let's revisit the example with ticketed system. So we have issue in airline company in their ticketed system where two passengers were able to book the same seat in the plane. So to avoid such issues, we need to use transaction isolation level repeatable read or serializable. This how it was implemented with the read committed transaction isolation level. So transaction begins, passenger selects a seat, 1.A, and marks it as booked. Another passenger comes in, checks that seat is still available because this transaction is not finished yet, selects the same seat and marks it as booked. Then transaction 1 inserts seat 1.A into the booking table and commit. And another transaction does the same. So in the end, we end up booking two seats. And the last update is this one, because this transaction commits the last one, overwrites it. With repeatable read transaction isolation level, it won't happen. Basically, this transaction will start, this transaction will start also, and it will be locked on this step. Then once this transaction will be finished, repeatable read will notice the anomaly and will abort this transaction. It will not allow it to happen. Okay, let's test it in Postgres. So one passenger comes in, this one, and he checks the seed. Seed is available. Another passenger comes in and also checks the same seed, and it's also available. So the first passenger does an update to book the seat 1.8, and another passenger tries to do the same at the same moment, but he won't able to do it. The transaction is locked. But we had almost the same thing in read committed transaction isolation level. Let's have a look at what happens next. Next, we inserting a new record into the booking system and say that this passenger books the seat. And as you can see, the second passenger got serialization error, couldn't serialize access due to concurrent update. And what he has to do, he has to retry. So even though if I will make a commit, that transaction will be rolled back, as you can see here. So he didn't make any changes. And if he will try to book the same seat again, let's start the transaction and let's have a look if the seat is still available. And as you can see, the seat is no longer available, so he won't be able to book it. The issue with ticketed system is solved. I hope this practical example will help you to memorize repeatable read transaction isolation better. Let's talk about phantom read anomaly. When can it happen? When a transaction reads a set of records twice and see different results, because a row has been inserted or deleted by another transaction that was committed after the first read. As you will notice, it's quite similar to non-repeatable read anomaly, but instead of changing an existing row, it inserts a new one or deletes an existing one. Okay, now we'll have a look at phantom read anomaly in practice. So I will use the same example with accounts. So basically we insert all of the accounts. In total, they have 20,000. And then one transaction begins. Firstly, let's just reproduce the issue with the phantom read anomaly. So select everything from the accounts, and then another transaction comes in. And instead of making an update, it makes insert with new account that called new high balance account, and it adds 8,000. And commits also. And the previous transaction does some operation. And as you can see, results are not consistent. If I will show this data in the report, we will see here the balance with 20,000 in total, but total balance in the result is 28,000. So it looks kind of off. To avoid such issues, you should use transaction isolation level repeatable read, which avoids phantom reads anomaly. Okay, now we'll see how repeatable read solves this issue. Let's do absolutely the same. I cleaned already the table to don't have the previous results. And we'll start a new transaction with the repeatable read type. Let's select information from the accounts. We see the same results. And let's start another transaction, which will insert a new record and commit. Commit has been completed. And now when I will do sum, I still will get consistent value 20,000, which is illustrated over here. Okay, as we can see, transaction isolation level repeatable read helps us to avoid phantom reads anomaly. Okay, let's talk about serialization anomaly, specifically write skew. When can it happen? It happens when two or more concurrent transactions read overlapping data and then make decisions based on the data they read, and finally write back changes. And those changes are not the same as if those transactions would run sequentially. Sounds a little bit complex as usual, but don't worry, grab your coffee, I will break it down for you. For better understanding, imagine the following example. An application for doctors that helps them to manage their on-call shifts in a hospital. It allows them to go off shift if they feel unwell, but it doesn't allow them to go off shift if there nobody else is left. So at least one doctor should be on shift. And here's the sequence diagram that shows how this application works, and that here could potentially be red skew anomaly. Okay, let's imagine that both of the doctors were infected by COVID and they feel unfortunately unwell and they would like to go off shift approximately at the same time. So here's Doctor 1, here Doctor 2, but our system should allow to go to off call only to one doctor because at least somebody should be in hospital and control everything. But unfortunately, with the right skew, this situation can happen. And let's have a look how. So here the Doctor 1 comes into the room and clicks button to go off shift. So it checks that Doctor 2 is available, he is on shift, so everything is fine, you can go off shift. And Doctor actually does it. And then another doctor comes in and does the same. And it also shows that Doctor 1 is on shift because the previous transaction has not yet been committed. And as well, the Doctor 2 goes off shift. So this operation and these operations are overlapping. And in repeatable read transaction isolation level, it occurred that both of these doctors went off shift. And nobody else is left in hospital to control the patients. So in case of the accident, can be a huge problem. Okay, as far as you're now aware about potential consequences of right skew, let's revisit the definition. So right skew happens when two or more concurrent transactions read overlapping data, so as these two, and based on the data they read, they make decisions. For instance, this one here, doctor see that Doctor 2 is on shift, so he decides to go also, and another doctor does the same, and then write back changes. So this makes an update and commit, and another one makes an update. And the result is not the same as if those transactions would run sequentially. So if this transaction would run sequentially, Doctor 1 would go off shift and another doctor would not be able to go off shift and probably would call for help. So this is an example already. Now see how it works in Postgres. So firstly, we need to insert the shift. So we have two shifts. Both of the doctors are on shift at the moment. And then first doctor comes in and would like to go off shift. So he checks if another one is still on shift. Yeah, the Doctor 2 is on shift at the moment, and he makes an update to say that I'm out. Another doctor at the same time comes in, checks available shifts. He sees that Doctor 1 is on shift, so it's fine to go off shift, and as well tries to go off shift. And then transaction 1, so Doctor 1, finish his transaction, and he was able to go off shift. And then Doctor 2 as well was able to go off shift. But if we'll have a look, now two doctors are off shift. So we were able to reproduce the bright skew issue, and if I would use Serializable, this issue would not happen. but we'll see this example at the next video, in the next tutorial. Hope it was useful for you. That's wrap for today. In the next video, we'll have a look into transaction isolation level serializable and how it solves write skew anomaly. Have a great day, and I'll see you in the next one.